This talk is about sensory receptors. These are the class objectives. You do not need to read them. We will use them to chart our talk. So let's start. What is a receptor? A receptor is a transducer that converts non-electrical energy into electrical energy, the currency of the nervous system, leading to sensations. Types of energy thus managed include mechanical, heat, kinetic, photic, and chemical. During somatosensory testing, we usually evaluate receptors that transform mechanical, such as when using a neuropin for pinprick, a cotton tip for soft touch, a turning fork for vibrations, heat or cold when testing temperature, and kinetic when using our fingers for manipulating the patient's limb during position testing. Which are the most important cutaneous receptors? I will mention 6. The first one is Pacinian corpuscles. They look like an onion with a stem inside. If cut as shown here, they look like concentric enlarging circles. They are found deep in the dermis. They respond to high frequency vibrations and pressure. They adapt quickly, implying that a stimulus, despite its duration, only produces afferent responses at the onset of the stimulus and at its termination. Pacinian corpuscles have a large receptive field. They send their signal through thick myelinated fibers labeled A-beta. The second receptor I would like to mention is Meissner corpuscles. Meissner corpuscles are often referred to as tactile corpuscles due to their high concentration found at the fingertips. They are rather superficial, being found just below the epidermis. They are only present in areas of the body with no hair. They appear as an ovoid structure with zigzagging fibers inside, as you can see in this histological preparation. Meissner receptors look like cotton candy. They are found just under the epidermis, as we previously mentioned. They are activated by light touch, by changes in position, and by low-frequency vibrations. They have a small receptive fields. They are supplied by thick myelinated fibers of the same type as the receptors previously mentioned, A-beta. Meissner corpuscles are quickly adaptable. The third type of cutaneous receptor I am going to mention is Merkel disc. They are found in the lower epidermis and upper dermis. They are present in hairy and not hairy skin. Merkel's discs have a small receptive fields. They adapt slowly, thus continue firing as long as the stimulus is present, or at least do so for a long time while being stimulated. Merkel discs are supplied by thick myelinated fibers, that is by A-beta fibers. They respond to pressure, position changes, and deep static touch. They are especially suited to determine shapes and edges, and for two-point discrimination. The fourth skin receptor I like to mention is Rufinis endings. Rufinis endings look very different when cut transversally, as indicated by the black line pointed by the arrow, from how they look when they are cut vertically, as you can see in this frame. Rufinis endings are present rather deeply in the dermis. Adaptation is slow, receptive fields large. They are supplied by large myelinated fibers. Rufinis endings respond to pressure and are very sensitive to objects' slippage along skin surface. The fifth receptor I would like to mention is free nerve endings. Free nerve endings are found in all layers of the skin, as you can see here. Free nerve endings consist of modified terminals of unmyelinated axons, that is, of C fibers, and modified endings of thinly myelinated axons. These fibers are called alpha delta fibers. Free nerve endings adaptation is slow. Unmyelinated free nerve ending responds to dull pain, deep pain, crude touch, warm and hot. Thinly myelinated responds to sharp pain, pricking, and cool and cold temperature. Unmyelinated and thinly myelinated fibers respond to chemical irritation. This is not tested during the neurological exam. The sixth type of receptor I would mention are those consisting of free nerve ending winding around hair follicles. These receptors, unlike free nerve ending not attached to hair follicles, are supplied by thick A beta fibers. These receptors respond to light touch and hair bending. Free nerve endings attached to hair follicles are quick to adapt, as indicated in this frame. Now I will address joint receptors. I will start by the following question: which are the most important joint receptors? 4 types of receptors are found in the joints. The first one, and most unique joint receptor, is the Golgi tendon organ. Here illustrated. It is an encapsulated structure placed in series with the tendon on one end and the muscle at the other end. You can see this arrangement in this histological specimen. The arrow points to the Golgi tendon organ. Just above, you see several muscle fibers. The nerve fibers carrying information from these organs are classified using a numerical system, unlike those from the skin that are classified using a letter system. They are labeled 1B fibers. The Golgi tendon organ gauges intramuscular tension. The second receptor I would like to mention is the Pacinian Corpuscles, which we have already discussed when talking about skin receptors, and I am schematically representing here. The signal from the Pacinian corpuscles present in the joint is carried by type 2 fibers. The Pacinian corpuscles are sensitive to pressure. The third receptor found in ligaments and joint is the Rufinis ending. They are present in the joint capsule, where these endings are very numerous. Information from these receptors is also carried by type 2 fibers. The fourth receptor found in the joints are free nerve endings. Free nerve endings perceive pressure, pain, and heat. The information is carried to the central nervous system using thinly myelinated and unmyelinated fibers. Thinly myelinated fibers are labeled 3 and unmyelinated fibers 4. Now we go to muscle, where we should ask ourselves the same question: which are the most important muscle receptors? Muscle receptors include Golgi tendon organs, innervated by 1B fibers, free nerve ending of thinly myelinated and non-myelinated fibers labeled 3 and 4 respectively. Annulospiral endings innervated by the fastest conducting fibers in the nervous system, the 1A fibers. Pacinian corpuscles innervated by type 2 fibers, and flower spray endings innervated by type 2 nerve fibers. Golgi tendon organs, annulospiral endings, and flower spray endings are involved in proprioception. Annulospiral endings and flower spray endings are found in organs called spindles. Spindles are encapsulated organs inside muscles that, in addition to the sensory receptors just mentioned, have small muscle fibers referred to as intrafusal muscle fibers. These fibers are innervated by gamma motor neurons. The spindle gauges length of muscle and speed of a stretch. The spindle is very important for muscle action because, by virtue of their muscle fibers, assure the maintenance of the same level of contraction at different muscle lengths, thus helping to maintain the same force at different muscle lengths. This is an striated muscle specimen. The arrow is pointing to a spindle. As you can see, the spindles are arranged in parallel with the extracapsular striated muscle fibers. Thank you.